Electrical charges make up the physics behind static electricity, oftentimes involving the balance between protons and electrons in an object. If an object has more protons, it has a positive charge, and if an object has more electrons, it will have a negative charge. But if the project is balanced between having an equal number of electrons and protons, it will have no charge or is deemed neutral. Static electricity is the imbalance of these charges, as most objects are inherently neutral. If two objects have the same charges, they will repel each other, but if they have opposite charges, then they will attract. Due to the conservation of charge, electrons are never made or destroyed in the process of static electricity. However, they are rather simply moved from one object to another. All charged objects have an electric field around them, and the strength of this field is dependent on Coulomb's law. This law states that as the distance between two charged objects grow, the force weakens, and as the two charges grow, the force grows by a factor of 4. I'll be using this PVC pipe to transfer electrons throughout my static electricity project to this homemade electroscope in my first experiment. The force of an electric field can be found by using the equation F equals K times the quantity Q1 times Q2 over D squared. In this experiment, I have my homemade electroscope, which is made of a glass vase, an insulated wire, and 2 aluminum leaves. As the electrons from my charged PVC pipe jump to the neutral wire and travel to the leaves both become negatively charged, so they'll repel from each other. And the more my PVC pipe is charged, the more electrons are sent, causing the leaves to repel further as the charge becomes stronger. In this first experiment, I took my charged PVC pipe, which was charged with electrons from my sweater, and sent them to the aluminum leaves down through the receiving end of the wire, which caused both of the leaves to have the same negative charge, causing them to repel from each other and push away. And the more electrons I had in the PVC pipe, the more electrons were sent to the leaves, causing the static charge of each leaf to be stronger, causing them to further push away. The second experiment is called a swinging serial experiment, where I will use a charged PVC pipe to cause this piece of cereal to swing left and right. I have a plastic cup taped to a string, which is tied to a Cheerio at the bottom, which starts off as being neutrally charged. I'm going to take my charged PVC pipe and transfer electrons to the neutrally charged cereal, causing the electrons in the cereal to be repelled and the protons to attract, which move the cereal over to the PVC pipe. And at the same time, once the cereal is full of electrons, now the PVC pipe and the cereal have opposing charges, like charges, so they oppose each other, and the cereal will no longer be attracted to the PVC pipe, causing it to swing away from the PVC pipe. With the stronger charge in the PVC pipe, it can pull the cereal a little bit more easily without being as close to it, which also in turn will take a longer time for all of the electrons to transfer to the cereal, as I can now pull the cereal piece more times than not. And now the cereal's full of electrons, so it is no longer attracted to the PVC pipe, no matter how close I'll get it to the cup. In this next experiment, I will be bending water using static electricity. So all I have is this running stream of water from the faucet and a charged PVC pipe, negatively charged PVC pipe. Using the negative electrical charge in the PVC pipe, I can pull the neutrally charged water towards the PVC pipe, causing the bending illusion that you can see here. And however, unlike the cereal, since each atom of the stream of water is neutrally charged, the water will continue to be attracted to the PVC pipe for however long the PVC pipe has or holds its negative charge, as when one neutrally charged atom of water passes by, it becomes negatively charged and then is repelled by the PVC pipe, but is also replaced by more neutrally charged water. Therefore, the entire stream as a whole stays attracted to the PVC pipe, not repelled. So I can continue bending water. The stronger my negative charge around the PVC pipe is, the more I can bend the water, and the farther from the water stream I can have an effect on the water stream. Thank you for watching my experiment on static electricity.